All right, welcome back. We are doing 3.7, number 18, and the directions are up here. And it says the graphs of the polynomials from the previous problems are shown. They're up here, right? And check your predictions. You were basically supposed to predict how many roots it had, and it's all based on the fundamental theorem of algebra. And the fundamental theorem of algebra basically says, hey, look, if your highest power is a 6, in this case it's a 6, right? X to the 6 is the highest power, then you should be looking for 6 roots. Now, if on your graph you only see, say, I don't know, 2 of them, it must mean that some of those roots are imaginary, and that's what you got to go look for. So for number 18, they want you to, number 1, predict. Okay, so here I'll ask you the question, based on the fundamental theorem of algebra, how many roots should this polynomial have? And so hopefully you say, oh, it's 4 roots. And I say, okay, well, why? Why is it 4 roots? And you say, oh, it's 4 roots because the highest power is x to the 4th. And you just told us that the fundamental theorem of algebra says if I have a polynomial of nth degree, so to the 4th, I should have 4 roots. Now, the 4 roots could be a combination of real and imaginary, but if you look at this graph here, it looks like I have 1, 2, 3, 4. I could see it hitting the x-axis 4 times, 1, 2, 3, 4. So in this case, it looks like these roots are all real. Okay, so once you find the roots, good, then use a graph to help you write the polynomial in factored form. Factored form looks like this: parentheses, parentheses, and parentheses. So what I'm going to do is I'm going to pull off my roots, just like I did here. And then I'm going to go backwards and I'm going to say, well, if these are my roots, what is its factor? Well, if x is equal to -3, then the factor is going to be x plus 3. And if x plus 3 equals to 0, then that must mean I have x plus 3 in a parentheses. So I'm just going to do these little steps backwards. So very common in math, right? This is a very mathematical thing for us to teach you something forward, and then for us to expect you to go now backwards through it, right? You learned adding, and then you learned subtracting, which, by the way, subtracting is backwards of adding, right? 3 plus what gives me 10 is the same thing as 10 minus 3, right? We taught you adding, subtracting, then multiplying and dividing, then squaring, square rooting. We taught you simplifying, which is PEMDAS, and then we started teaching you solving, which is SADMAP, right? And then there's other things that you all learned in integrated 3, like, for example, you learned exponentials in integrated 1, and then we learned the backwards of that, which you all know as a logs, like taking the log of both sides. In calculus, you learn just 2 more functions. You take the derivatives of something, and then you can undo that by taking the integral or the antiderivative of that. So math, you always are doing this like forwards, backwards thing. And the more you understand how to go forwards and backwards, the stronger your logical reasoning and critical thinking comes into play. So you're considering this problem that you're having. You're like, oh, well, how can I undo some of these problems? And that's undoing problems is basically algebra. You're welcome. Just kidding. All right, here we go. So I'm going to pull off the roots here. So let's see. I see it looks pretty good at -2, at 0, at 1, and at 2. Now, when I say it looks pretty good, it's not showing up in between, right? It's not an in-betweener. It's actually like right on spot, right? So very first thing I'm going to do is write out all my factors. So I said x is equal to -2, x is equal to 0, x is equal to 1, and x is equal to 2. Okay. So because these are my zeros, then I'm going to go up a level and I'm going to write out their factors. Okay. If this is the 0, then what's this guy's factor? Well, in your head, I want you to think about this. How can I set this equal to 0? So I have this -2 over here. How would I move him over here? And you're like, oh, just add 2 to both sides. Very good. So then this would just be x plus 2. Do you see how the root is related to the factor? Very good. And then this one's already equal to 0. I'm just going to bring him up a level so he's all on the same kind of like level so I don't forget about him. And then x is equal to 1. So if x is equal to 1 is my root, what is its factor? And I'm thinking, how can I make that equal to 0? So then you're like, oh, just subtract 1, Miss Johnson. Very good. And then last but not least, x is equal to 2. Very good. X minus 2. So here's that line above it, right? And then the line above this, like if I gave you this in factored form and I said, okay, find your zeros, then you would set each one equal to 0. So then the one above this just looks like this. X plus 2 times x minus 1 times x minus 2. And this is all equal to 0, right? But in factored form, it would just be this right here. So there you go. I'm saying this is equal to this. Those are the same. Okay. So then I'm just going to erase off my equals to 0 because I don't need it, because I'm not trying to find my intercepts. That's actually how I found this. And so this is it. I'm going to do a quick check here. My first quick check is going to multiply all my first. So x times x times x times x. Is it really x to the 4th? And you're like, yes. Okay. Then the last thing, I'm going to multiply all of my lasts, right? My lasts. So Ms. Johnson, is this considered a last? It is and it isn't. So I'm going to not multiply it and then see if I need to multiply it, right? But it actually is, just so in case you're wondering. So 2 times x is 2x times -1 is -2x times -2 is positive 4x, right? So then it works really well. The other ways I've shown you how to do this is if I pull over my best friend Desmos and then I plug this in and then it shows up like this. And then I plug this in and it shows up right on top of it. That means I know that I'm right. And again, that's my favorite part about math. Okay, that's a lot of explanation. I probably won't be going through that much explanation for the rest of these, but I wanted to make sure that I hit all the major points of this. So again, here, according to the fundamental theorem of algebra, how many roots should I be looking for? Very good. If you said 2, you're awesome. Good job. And you're like, Ms. Johnson, there's only 1. Yeah, and actually this one, the way I like to explain it is this one, it's almost like the answer is 3 twice. And I can show you why that is. I can kind of show you why that is. So I'm just going to pull off I'm going to go forward with how I would normally do this. So I would write, all right, my answer, my root is x is equal to positive 3. And then I would go backwards and I would go x minus 3 equals to 0. And you're like, Ms. Johnson, there's only one factor. And you told me that I should be looking for 2. So then I'd say, wait a second, hold on. Let me factor this thing really quick and see what I actually get. So if I was to factor this thing, and I'm going to just factor this one in my head, right? So the very first thing is I don't ever factor when x squared is negative because I don't know, it just kind of bugs me. It's just my preference. You can do that, but I don't do it, right? And then so what I'll do is I'll take my negative out and I'll go x squared minus 6x plus 9 equals to, not equals to 0, but I mean, essentially equals to 0, but yeah. Hold on, let me let my computer catch up to me. Okay, and it's not. Hold on a quick second. Okay, so when I factor this x squared minus 6x plus 9, it turns into x minus 3 and x minus 3, right? So do you see how you have x minus 3 twice? So therefore 3 is a root, and we in the math land say this is a root of multiplicity 2 because it's coming in there twice. Now I could tell as a mathematician that this is a double root. Sometimes we call it a double root. The reason why I could tell this is a double root is because how it approaches the x-axis looks like a parabola. Do you see this? How it approaches the parabola. It doesn't go through the parabola. It approaches it just like a parabola, and then it comes back down. So this is telling me that this is a double root. Okay. So if you look at this one over here, this is a single root. Ms. Johnson, how do you know this is a single root? Because it kind of like, if I zoom in at this little tiny window, it looks like a line right here. And this looks like a line just in that little tiny window. Like if I was to draw like the tiniest of tiny windows, like boop, right? If I drew in this tiny little window, right, that looks like a line. Same thing here, same thing here, same thing here. But here, there is no doubt that it's something different is happening. And so one of the things that you'll notice is whenever you have a double root, it'll act like a parabola at that point. Now you're like, Ms. Johnson, this is a parabola. I know, but look at this guy over here. Do you see how he's acting like a parabola at that point? So at that point, I'm probably going to get a double root. Okay. Sometimes it's not a double root. Sometimes it's even greater than a double root. Okay. So let's move forward. So if I wanted to write it in factored form, I would write x minus 3. And now that I know that it's a double root, I would have written it like this, x minus, so I would have written x equals 3, x equals 3, x minus 3 equals to 0. And then I would have written x minus 3, parentheses, x minus 3. And I know what you guys are all saying is, oh, Ms. Johnson, don't forget the block. I'm forgetting it on purpose so I could check. It is not catching up to me, so I'm trying to be patient. So if you don't know what I'm saying, oh, you don't forget the blank. There's a negative out here that I'm specifically forgetting so that I can show you how I'm checking. And then it's okay if I make mistakes, right? It's okay if you make mistakes. You just have to put things in place to make sure that your mistakes don't stay as a submitted answer. Does that make sense? So here I'm pretending that this is my answer. So I'd multiply. Remember, I told you the very first thing I do is I multiply first times first times first. So in this case, it would be x times x is x squared. Dun, dun, dun. It is not negative x squared. What shall I do? Oh, that's easy. Just throw a negative all the way out in front and you're done. Ms. Johnson, how come the negative didn't come out here? A couple of reasons it didn't come out. I mean, there's a lot of reasons it didn't come out, but one of the reasons is because when we focus on zeros, like this 0 in and of itself is just x is equal to 3. Now you can think about all the different ways that I can write x is equal to 3. I can write negative x equals to negative 3, right? And all this other different ways, but I don't do that. I just go straight for the number. The other way that I could have checked and I would have instantly seen that this was wrong was if I was to graph x minus 3 times x minus 3, right? This guy, it would have given me a parabola like this, right? And then this guy here would have given me this parabola here. And then I would have been like, oh, I forgot the negative. So there should be a lot of like little checkpoints along the way. And I'm hoping I'm hoping I'm showing you all the little checkpoints. Because the more checkpoints you set up for yourself, like who cares if you make mistakes? You have a checkpoint waiting for you to make sure that you didn't miss it, right? Like I do this all the time for myself. Like I have alarms set on my phone for a bunch of different things. There's like a podcast that I really, really like listening to, and it comes on at 4:00 on Thursdays. And sometimes when I'm getting so into things that I'll forget, but I have an alarm on my phone that's set off 15 minutes before that reminds me. So there's a checkpoint there. There's also checkpoints for me to start and end this class because we don't have bells, right? So there's a lot of different checkpoints that I use to make sure. Okay, last one. So this one here, I already kind of prefaced you and I said, hey, this is a double root right here. So even though I only see 1, 2, 3, 4, 5 roots, okay, when I only see 1, 2, 3, 4, 5 roots, and it's telling me to look for 6 of them, oh, he's a double root. Oh, okay, Ms. Johnson. Hey, Ms. Johnson, can we have more than a double root? Like, can we have a triple root? Yes. Can we have a quadruple root? Yes. Can we have like 100th root? Yes. You could have as many roots as you want, like with multiplicity, whatever. Just it'll just show up that way. But here I'm trying to give you a clue on when you're looking at a root, how to tell if it's a double root. And then later on, I'll show you how to tell if it's a triple root. But right now, you should be able to count. This is definitely a single, a single, a double, a single, a single. And if you count those, that's 1, 2, 3, 4, 5, and 6. So I'm going to do this fairly quickly. So I get x equals to -2. Is that -2? Yeah. X is equal to -2. I get, oh, that's way over there. Let me scoot my paper over here. Scoochie over. Okay, so x is equal to -2. I get x is equal to -1. I get x is equal to 0. X is equal to 0. Ms. Johnson, why did you write it twice? Again, because I want it to get up to the 6th, I've got to write all 6 roots out individually. X is equal to 1 and x is equal to 2. And some of you are seeing the symmetry of this. Do you guys all see the symmetry of this? Notice the symmetry of your roots, right? That makes sense, right? All right, so then in that case, you should be able to write out your factors or their factors relatively quickly. I like to link these two, so I call it, if this is the root, who's its factor, or if this is his factor, what's its root. So I like to link them together like they belong together. So this is going to be x plus 2 equals to 0. This is going to be x plus 1 equals to 0. This is x is equal to 0. X is equal to 0. X minus 1 equals to 0. And some of you are thinking, Ms. Johnson, do I really need to write this step? No. Like some of you are so good at this, you can go from here all the way back up to the factors. And I like that. Just be careful and make sure you have checks along the way. I'm merely writing this out for the benefit of you all. So here's my my factored form. So x plus 2, x plus 1, x minus 1, and x plus 1. And I'll clean this up just a, oh, did I say that wrong? I did say that wrong. Hold on, sorry, I messed up. X minus 2. And I'll clean this up just a little bit, just so you can see, like, because you won't necessarily see it like this. You'll see it cleaned up, looks like this, x squared, and then just all the factors. And it doesn't matter which order you put them in. I tend to put the pairs together. Do you see the symmetrical pairs? X minus 2, x plus 2, x plus 1, x minus 1. I like to put those together. But that's really it. That's how you would factor based on the graphs that they gave you. It's nice when they give you really clean roots like this. It gets a little bit more difficult when they don't give you clean roots like that. And we'll talk about that later on. But hopefully you're seeing this relationship. So let's scroll back up and over. Hopefully you're seeing this relationship between the roots and the factors, right? The roots and their factors. And then also with the nth degree polynomial with the number of factors that you're finding. I know it seems like this is a lot of work, but it should make sense, right? And that's my favorite phrase. Math may not always be easy, but it should definitely make sense. Thanks.